today's topic is going to be going deep into signals change detection. Before I go into that, I'd like to introduce myself. I'm Enea Jahollari. I come from Albania. I am a GDE for Angular. I'm also a software engineer working with push-based on performance issues mostly, design system, and architectures. And let's get going. So I hope today's trip on this slide deck feels like a lot of fun. So let's see how it goes. So let's say we have a normal app component with a count that we show and the button click. And then when we click, we just increase the count. And the question would be, how does, let's say, Angular know to update the DOM? So when does it know that something changes? Maybe it runs some change detection on every event that happens. Something like if we have the onClick, maybe after the onClick, we have some Angular magic code that says run change detection, so just synchronous things. So let's say we have the onClick, but what if we use some set timeout? So let's say we schedule that, let's say, count increase for later. So, and then what happens if, let's say, we run this code? Basically, what would happen is first we log before with a count 0. Then because it's synchronous, we log after and the count is still 0. And then we have count up increase inside the set timeout. And then, of course, we log the change part. So after 1 second, and that count there would be just 1. So if we use the same logic as we used before, we have Angular.run change detection synchronously. So probably we have before, after change detection, but at that point, the count is still 0. So this logic doesn't apply. So what we need to do is to move that Angular change detection call inside the set timeout, so after the timeout finished. And of course, it will look something like that, and our penguin will be happy. And if you remember, like Angular.js code, something like scope.digest to support this asynchronous code, let's forget about it. Angular change detection is better. So how to run code after some asynchronous event? Well, Angular solved this issue in 2014 with Zone.js. So what is Zone.js? Well, here's a video. You can look later, but I'll just give a short description about it. So Zone.js basically monkey patches almost all the browser APIs in order to get notified whenever an event happens. So it's like if you have the browser as a box, Zone.js will wrap this box, and anything that goes in or out, it will know, and it will notify Angular. So everything like add event listener or onClick, on mouse down, everything, set timeout, set interval, XML, HTTP request, promises, request animation frame, alerts, confirm, prompt. There's a big list. You can check on the link. So Zone.js is like, OK, I'm listening to the browser, and it's like a guard there. And let's now go into some real-life stuff. Let's say we have this movies app. And of course, Angular is, let's say, composed of components. So we have app components, sidebar, navigation item, movie list, widget bar, everything else. But if we convert that to a component tree, it will look something like this. And then we have the application ref, which is at the top. And if you ever did like bootstrap application.then, and you checked what that, let's say, result is there, you probably will have seen the application ref reference. And the application ref has some methods that we can use. But most of the time, we don't, maybe. So Angular with Zone.js is like this tree of components, but wrapped with Zone.js. So Zone.js is listening to this tree. So what Angular also does is, after Zone.js that we import in every Angular application today, after it, let's say, is imported in our browser, so browser fetched it, Angular, what we'll do is create a fork of that bigger zone that wraps the browser. And of course, create the ngZone class. And inside ngZone, there is an observable or event emitter, which is an observable, that says on microtask empty. And that on microtask empty basically will say, whenever there's no more microtasks, please notify me. And Angular uses this observable, so subscribes to it. And every time that observables emit, basically it goes and says application ref.tick. So we have a tree of components, Zone.js, and when that onMicrotask empty fires, it goes to application ref and calls tick. But what is this tick method? Well, remember that imaginary Angular.run change detection? Well, that's mostly it, somehow. So if you go into tick implementation, on the Angular source code, we'll see this detect changes in attached view. And what it does is it iterates through all the root views and calls detect changes. You probably have used detect changes when you import mark4check, but that's the same thing. So we have, by default, two change detection states, which is skipped. So there's this component that Angular did nothing with it, so it's just there. And then we have refreshed bindings. And refreshed bindings means that we have Angular running update phase for the component, but also all the lifecycle hooks after viewing it, after content checked, after view checked. I don't remember the other, sorry. So when this tick happens, Angular goes to app component and runs detect changes. And of course, detect changes will refresh that component. And after that, it goes to the first branch, runs detect changes there recursively, so to component and all its children. The same thing for second, third, and fourth branch. But basically, Angular refreshes bindings top down. And of course, refreshes means if the previous value is different from the new one, this value, I mean the stuff that we have used on the template, like count before. If it's different, then great, update the DOM. If not, then skip any DOM update, so don't do any work. So how to skip checking everything every time? Well, dirty marking plus OnPush to the rescue. So dirty marking is a concept where we use in Angular a lot. And a component is marked as dirty by event listeners and click, like click mouse over, or output emissions. They use the same mechanism under the hood. So if we look at the internal code, Angular has this method called wrap listener, and inside of it has wrap listener, mark dirty, and prevent default. And what that will do is call that mark view dirty function every time we have a click or an event on the template. Then we have changed inputs using, so when we use changed like set input, so component ref.set input, that thing will also call mark view dirty. But what's the other one? Any ideas? Well, you didn't find it, but it's just mark4check. Mark4check basically calls mark view dirty, same as all these other APIs. So Angular for dirty marking uses the same API under the hood. And this mark view dirty, what it does is it marks the current component as dirty, but also all the other ancestors or parent, and of course, until it goes to the root, which is probably app component, and marks them as dirty. So we have another state now, which is the marked as dirty state. But marking as dirty doesn't mean anything. It means just a flag was updated internally that says, this component is dirty now because something probably changed there. So with this thing in mind, let's say we have a button click now, example. And then we have a button, like a +1 there. And then we click on the button. And then we have now, let's say, Angular calling this wrap listener in mark view dirty and prevent default. And what this will do is call mark view dirty. So what we do is we mark the current component up to the top and ancestors as dirty. But don't forget about Zone.js, because now we have Zone.js, which gets notified by the click, because Angular basically uses add event listener under the hood. So we have Zone.js now that gets notified by the click. And after everything is finished, so there's no more work on the microtask queue, on microtask empty gets fired, application ref.tick gets called, and Angular goes on app component and says, refresh everything top down. So that's an issue there because we're refreshing too many components unnecessarily. Let's use OnPush and optimize it even further. I believe everyone here knows how to enable it. Go to component decorator, put change detection strategy, and put OnPush there. And then with OnPush, we have some other change detection states. We have the OnPush one, so just when we put OnPush, Angular will mark it as an OnPush component. And this OnPush component will be refreshed only if the inputs were changed or updated. And of course, it uses triple equals check. And then we have OnPush and dirty, which means this OnPush component is marked as dirty and will be refreshed on the next change detection. So let's say we mark two components as OnPush, the first and the second one. And then we do the same click thing. We click on the button, mark ancestors as dirty, microtask empty, kicks in, application ref tick, Angular go to app component, and run detect changes. Now, let's say we don't have input changes on those two components. So what will happen is they will be skipped. So they won't be checked anymore. So their children won't be checked. But all the other parts of the template will be refreshed, just like normal change detection. So we have them skipped. But if, let's say, on the first branch, we have some input change, that branch probably will be, not probably, it will just be refreshed just like normal, because we say OnPush plus dirty, always refresh. Of course, the second one will be skipped. Let's mark three components as OnPush. And then we have the same process again, but now, when we go with change detection on this OnPush and dirty, as we said before, we also refresh that one. And that's what happens, just normal refresh. So basically, with default change detection, we have too many checkings, not refreshings, also refreshings. And with OnPush, we skip branches and do less checking, because we know that nothing changed there. But what about the async pipe? Because, hey, async pipe and OnPush improves change detection somehow. But I don't think it does do any wonders, because it just uses mark for check under the hood. And if we look at the internal implementation, we see that update latest value will just use change detector ref.mark for check. So if we use this async pipe, we should have the same, let's say, behavior as before. So we have three components as OnPush, and then we have async pipe on our component, and well, we didn't click. So what triggers the tick? Let's say on this observable with async pipe, we have an HTTP request. But HTTP request uses XML HTTP request under the hood. But that's patched by Zone.js. So there it is. That triggers a tick. And if we have like a click and then we update that observable or a behavior subject, then we have the click handler that notifies Zone.js. And if we do just to do that next, like synchronously, that's synchronous code, and Angular always just updates it normally. And of course, calls on init on every, let's say, component initialization. But if we have set timeout, we have set timeout, which is also, let's say, patched by Zone.js. And what if we put this set timeout to run outside Angular zone? Will this work? Because now zone won't be notified anymore because it's running outside of it. Well, is it broken before v17? Yes. It wouldn't do anything. Your application probably will be in a broken state. But in v18 and later, it just works. And I'll show you how. So Basically, async pipe does the same thing and is, let's say, affected by the same Zone.js patched stuff as the other events. So we have top-down refreshing again. But the question is, why do we need to mark all the ancestors dirty? Why not just mark that component where the change happened? Well, let's do that. Like, we have to do async there, and then patched event notifies zone goes top-down refreshing again. Then we have app component that goes tick. Then we go to this OnPush component, but it's not dirty. So our rules say OnPush component, which is not dirty, we skip it. And what happens is that now this component was skipped because the main branch, the branch itself was skipped. So it's not updated. And of course, that brings you to a broken state. That's why we need to mark all the ancestors as dirty. Well, can we do better? Yes? No? Any idea? Yeah, I'm sending you signals. I believe all here know how to use signals or create one. Eliran also created some signals live on the stage. So signals are cool. What's even cooler are effects. They just know when a signal that's called inside of them changed. And if we use also set timeout and change the signal later, effect will still be triggered or, let's say, scheduled to run at some point, defined, of course, by Angular itself. So if we use now a signal on a template and we try to update it, what Angular will do is start to treat templates as effects, or as we call it, consumers. Effects are consumers, but I like to call them effects, in quotes. And now every time a signal that is read inside a template is updated, that component will be marked as a refresh view. A refresh view is now what that signal change detection brings to the table. Just some new flags internally. And any time that Angular does change detection or top-down refreshing, it will go on each node and see, OK, if this is a refresh view, then I should always refresh this no matter what. And what's another flag is this has child views to refresh. And what this will do is this basically will be applied on all the ancestors of this refresh view, let's say, component. So let's see this in action. Let's say now instead of the click binding or the async pipe, we just have a signal in our template, a to-do signal. Of course, the moment that we call something like onClick set, that signal will mark that component template or consumer as dirty. And at the same time, it will do the same thing as the dirty marking did, go all the ancestors and mark them as has child views to refresh. But in v17, signals still rely on Zone.js to trigger the tick. So basically, when we update that signal, we have the Zone.js that gets notified, microtask empty, application ref tick. Angular goes down on app component and now sees this has child views to refresh. What should I do with this? Well, that's where the new change detection mechanism comes in. That's called targeted mode. And targeted mode was introduced, but before that we have something else called global mode. And in global mode was a default change detection that I showed you before, where Angular, anytime it goes top-down, it says, I will refresh every component that has default change detection set, like nothing set there, or if it's OnPush and dirty, or the signal inside of it, or the inputs changed. And then we have the targeted mode, which now will be activated every time Angular goes and checks if I have an OnPush component that has child views to refresh. Then it will go and refresh only the components that are marked as refresh view. So what happens is we have app component now. We need to do some top-down rendering. And then we have app component, has child views to refresh, but has default change detection. What happens is we are in global mode by default. And then on global mode, every component that has default change detection, we just refresh. And then we go to the first one. We are in global mode. We are on OnPush. Not dirty, so we just skip, go to the second one. We are still on global OnPush, not dirty, and we also skip. And then now we have this OnPush component that has child views to refresh. And what we do here is we skip. But at the same time, we convert to targeted mode because that's the rule that we applied before. And what we do is now we traverse down to the children and go, we are on targeted mode, but with normal change detection. But we said that on targeted mode, we only update refresh view. So this one, sorry, we'll have to skip. Now we are on a targeted mode and refresh view. What we do here is we refresh. And every time that Angular goes and refreshes some refresh view, it goes to global mode again. The reason is backwards compatibility, because now, even if we have signals, we can still use default change detection components inside of signals. And those also need to be updated. So this way, Angular doesn't break the old components, but also introduces this new optimization of the change detection. So we are on global mode, normal change detection, refresh. Go to the last branch, normal change detection, global mode, refresh, refresh again. And I think before we had to refresh a lot more, so this looks way better. But don't forget, the only thing that triggers it is if we have OnPush components and has child views to refresh. That means we'll have to use a signal in the template on the tree, but also have one of the ancestors or the component itself as OnPush. So these new rules get applied. Let's add more components. So if we have that, it will look something like this. So instead of rendering the whole tree, we only render one component. And that, to me, looks like local change detection. So only at the component level. But you'll need to use OnPush. And with signals, that's even easier, because, as I said, Angular will apply new rules that will always make sure that everything changes and gets updated. So we had this question in the beginning. So how does Angular know when something changes? Well, there's these three things that we just explained. So Zone.js, so all the events that happen on the browser. Mark for check, that, let's say, Angular has called since the beginning internally to dirty mark everything. And then now we have this cool signals thing. I believe we all have heard of the new zoneless thing. So going zoneless means we just cross out Zone.js from the equation. And we're left with mark for check and signals. So with Zone.js, we had something like this, something that is wrapping the whole, let's say, component tree and listening to every single event that's happening. And with the new zoneless thing, we have this change detection scheduler thing, which basically it's not wrapping the component tree, even though it looks like this, in order to make this, let's say, even easier to switch the mental model. So what change detection scheduler will do when it gets notified is it will make a race between request animation frame and set timeout, and which one of those goes first or wins. Then, based on that, it will schedule the new tick, because change detection scheduler also uses tick under the hood. So it looks something like this. They run, and which one wins, that's what we use. So with Zone.js, we had browser asynchronous events, which were triggering change detection. Advanced listener, onProp, already explained that. And then with change detection scheduler, we have Angular own, let's say, changes or updates. So things like a signal update, a listener, so a click listener or any kind of listener. We have set input when we attach a view, when we detach. Anytime we have animations that are loaded, or render hooks after next render or after render, defer block state updates. And then we have this thing called mark for check. This means that in V18, if you use mark for check, you're not just dirty marking, but you're also scheduling a new change detection. And this is how mark view dirty looks under the hood now. So basically, it says, change detection scheduler, please get notified because I want to run change detection at some point, whenever you want. I showed this piece of code before, and I said in V17 it's broken. But now, if we have that to do on the template with an async pipe that calls mark for check, even though it's running outside zone, that will still work, because now we have mark for check, which triggers change detection, and not just dirty marks things. This means that if your application is on push, and you're using mark for check or async pipe or push pipe or NGRX push pipe, they all use mark for check under the hood. You can just go zoneless, because that's all you need to go zoneless. So this signal thing and zoneless are two different things. And they are great when they are used together because of better developer experience, but they are not, like, let's say, required to be used together to bring zoneless to your apps. But how we can bring zoneless is, first, we go onto application providers, and we say, provide experimental zoneless change detection, and that will bring the zoneless change detection scheduler to be used. Of course, it's still experimental, but if you start, let's say, using it only maybe on, let's say, development mode and not on production, then maybe you still get the benefits. But also, you also remove this 15 kilobyte of JavaScript that needs to load on every Angular application that is today in production. But also, I say it's better to use in development mode because it improves debugging. If we look at stack traces with Zone.js, it will look something like this. So we have app component template, click listener. It goes to execute listener, and then wrap listener with mark view dirty, and then invoke task, can invoke task, on invoke task, run task, any kind of task. We don't care, task, task, task. But without Zone, we have click listener, wrap listener, mark view dirty, and call the changes that you made, nothing else. I hope it was something like fun and not something like crazy. So what I want to say is you don't have to care about all this. It's Angular's job to do that. As I said, if you use signals, you should be safe from any change detection issues you had before, also with mark for check and zoneless. So the whole idea is for Angular to deliver web apps with confidence. And that is by making it performant with the new change detection modes, by increasing the developer experience, so bringing signals to the table, and being stable and reliable, meaning it doesn't break old applications. So you can just migrate to the latest Angular, use the same code base, nothing will break. But now you'll have the possibility to use these new things incrementally. As I said, you just need an OnPush and a signal, and you just trigger these new change detection modes that improve at least performance or bring that local change detection that some of us really need in our applications. And there are also libraries that help you with signals. We have NGRX, which introduce select signals, but also signal store. We have RX Angular, which has full support for signals in template directives, but also in RX state. And then there is ng extension, which I co-founded with Chao, that basically has signal utilities that you can use in your apps, but also signal migrations. So you can use it to migrate to signal inputs, signal queries, new outputs, inject migration too, but all of those probably will be deprecated because Angular will bring their own tools, which are tested on Google. So that was change detection, Zone.js, and signal story for me. If you want really good performance, so even more than just local change detection, but template level or, let's say, completely view-level change detection, you shouldn't miss Julian's talk tomorrow. It's really good. I promise. So if you want the slides, you can scan it here. Thank you.